Hello and welcome to today's lecture on data dissemination in wireless sensor networks. So let us start with the lecture. Now, data dissemination. It is a process in which sensor nodes collect the data and communicate to the base station or any other interested nodes. Now, it is a complete process of circulating the data or passing on the data or broadcasting the data and communicate that particular data with either the base station, either the sync node or any kind of other interested node. Here, in this complete data dissemination process, we have three main entities. So the first entity is the source node, the second entity is the sync node, and the third entity is called the event. Now the source node is that particular node which is interested in sensing the data and which is responsible for generating the data. Now this source node has all the data which will be forwarded or which is required by any other node or the destination. The second entity was the sync node, the node which is interested in any particular type of information or data and which seeks the information from the source node. The third entity is an event. Now an event is nothing but an information which needs to be reported to the sync or the destination node. Now the objective of the wireless sensor network has always been to send the data from the source node to the destination node, and this destination node can be known from various names, like we can call it a sync node, we can call it a destination node, we can call it a header. So the main objective is to transfer the gathered data or an event from the source node to the sync node. Now this entire data dissemination process is of two steps. In the first step, what we are doing, that interested nodes are broadcasting to their neighbor node in the network. They are broadcasting for seeking some information or seeking the event. And in the second step, after receiving the request from the sync node or from the interested node, the source node starts sending the data or source node starts broadcasting the data to all its neighboring nodes. So it is completely a two-step process here. In data dissemination, there are various methods through which the data can be transferred, can be sent, and can be collected. So let us now have a look on these different types of approaches of data dissemination or data gathering. There are mainly three types of approaches for performing data dissemination in the wireless sensor network. The first approach is flooding. The second approach is gossiping, and the third approach is called spin. So now let's look into all these types of approaches in detail. The first approach is flooding. Here, the node broadcasts the gathered data to every neighbor node, and it does this function and repeats this complete cycle until the maximum hop count is reached or the data has been delivered to the destination. Now, what is it? Each time, every node broadcasts the gathered data, and this process continues, forwarding, broadcasting, continues until the packet has been delivered to the destination node. Here, the sent data are broadcast or the data need to be sent or broadcast to all the neighboring nodes. The receiving node stores a copy of the data and sends a copy to all its neighbors. Let's look into this diagram and understand the concept of flooding in a little bit detail. So here what it does, let's suppose A is a source node and it receives a broadcast request. So what it does, A broadcasts the event or it broadcasts the data to its all neighboring nodes. But here as we can see, A has only one single neighbor which is B, so it broadcasts the data or it forms the event to B. Now B, when receives that data, it stores a copy of that particular data and it again broadcasts the data to all its neighboring nodes. Now B, as we can see, has 4 other neighbors except A. One is D, another is F, then E and C, right? So B, what it does, it broadcasts the same message to D, to F, to E and to C. This is how flooding works. Again, when D receives the message from B, it broadcasts that message leaving B to all its neighbors. Now D is having D and F. As we can understand, B has already sent the message to D, so it will broadcast the same message to F. And this is how the entire message is flooded into the network. Entire message is sent to the destination node. But as we can understand, as we saw in the diagram, B is sending the data to all its neighboring nodes. Again, D is sending the data to F, which data has already been received by B. So, as you can see, there must be some limitations of this concept. There must be some demerits of this concept. The first limitation of this concept is implosion. Now, implosion, we know flooding works on broadcasting, so there is no restriction on sending the packets. In this way, multiple nodes send same packets to same destination. Now, let's see. Implosion occurs when node sends data to its neighbor, regardless of whether or not the neighbor has already received it. Let's go back to the diagram and understand this point. I said implosion, regardless whether the data has been already received, a node broadcasts that data. It doesn't care whether the receiving node has already received the same data from other nodes. So in this way, what happens when B is sending the same data to F, E, C and D is sending the same data to F which has already been received by F from D. So what happens? F is having the same redundancy or a duplicacy of data at received from D and B. So here same packet or same data has been received from a single node from two multiple nodes B and D. So F is having the same duplicate data received from B and D. This is what implosion is. Second approach is overlapping. Now I'll show you with the diagram also here. You can see implosion. A is sending the data A, let's say, to B and C, and B is sending A to D. Let's suppose D is the destination node and A is the source node. So source node send A data to B and C to both the neighbors. B is sending that particular data to destination node D and C is again sending the same data to D. Now D is having now two copies of the same data, right? So this is what implosion is. The second approach is, second limitation is overlap. Data overlap here we are talking about. It occurs when the sensor nodes cover overlapping geographical areas. Now, what is overlapping geographical areas? Let's look into this image. Now, in this diagram, as you can see, we are having three locations, Q, S and R. The black region, you must not be able to see R, but here are three regions. We are having three geographical regions. One is Q, one is S, and another is this black complete triangle. This is R. Now, what are we having here? A and B are two sensor nodes where A is sensing the data of Q and R and B is sensing the data of S and R. Now R is, this is the overlapping region, so A and B both are reading the data of this R region because they are, this area is coming under both these Q and S geographical area. Now what happens at the time of broadcasting or flooding? A is sending the data of Q and R region to C node and B is sending R and S data of the R and S region to the node C. Now here as we can see, the overlapping of our area is making the delivery or the flooding of the same data to the node C. So this is what overlapping or data overlap means, that the neighbor nodes are receiving a duplicate or the redundant message of a overlapping area, geographical area. Now this of course leads to the wastage of energy and wastage of bandwidth also. The third limitation of flooding is resource blindness. Now, resource blindness occurs when nodes do not modify their activities. You know, they are flooding the data and irrelevantly, regardlessly whether the neighbor has already received it, whether there is redundant data, whether there have been multiple copies of data received by the destination, it is not taking care of all these activities. It is not being energy efficient. So what happens? It occurs when the activities are not being modified based on the amount of energy available at a particular time. Now, of course, we know we are having sensors, we are having some particular devices, and these devices are working on the battery, or they are working on a limited range of bandwidth. So here we in resource blindness, any node or the entire network is not caring about the energy efficiency. And this energy efficiency can be of a particular node also, and it can be of the entire network. So these are the limitations, and as we have studied the limitations, in the next approach, when we are developing the new approaches, we are always working to remove we are always working towards removing the limitations and improving the previous approaches. So let's look into the next approach, which is gossiping, and here we are trying to remove the limitations of the previous approach, which was flooding. So in gossiping, each node floods all its data to one randomly selected neighbor, right? So it is an enhanced version of flooding, where the packet is sent to a single neighbor node. It is not sent to all the neighboring nodes as we saw in the previous approach. Here, a single node will transfer the data or send the data or perform the event to any particular node. And this node is not particularly decided, it is chosen randomly from the neighboring table. Right? So the packet is sent to a single neighbor node chosen from the neighboring table randomly, instead of broadcasting each packet to all the neighboring nodes. Now what happens? This approach avoids the problem faced by the flooding, which was implosion. It avoids the problem of implosion, and it also contributes to the latency of the network. It improves the latency of the network. Now let's dig into the third approach of data dissemination, which is called SPIN, Sensor Protocol for Information via Negotiation. In this approach, in this method, we are mainly incorporating negotiation and resource adaptation. Now, negotiation and resource adaptation have been incorporated in this approach, so that we can overcome the limitation, we can overcome the demerits of the first approach of data dissemination, which was flooding. Now, first of all, let's see what is negotiation and resource adaptation means. Negotiation means the nodes negotiate with each other before transmitting the data to ensure that only useful information is transferred. Now, this time, rather than just flooding the data or broadcasting the data regardlessly, unnecessarily, we are discussing, we are negotiating before transmitting that data to every particular node, so that only the information which is required and which is useful is transferred in the network. Now, this negotiation eliminates implosion and overlap, of course. So the two demerits of the first approach, implosion and overlapping, is eliminated through negotiation, by using negotiation. The second word we got to know in SPIN is resource adaptation. Now, resource adaptation, each node has its own resource manager, which keeps the track of resource consumption. Now, the third demerit of, as we know, the third demerit of flooding was unnecessary use of resource, which was resource blindness. So now we are having the resource manager. We have kept the resource manager, just like operating system is our resource manager of our system. So in the same way, in every sensor node, we are having a resource manager, which is keeping the track of all the consumption of the resources that has been done by the node. Now, what it does, the nodes poll before the data transmission. Now, every time a data needs to be transmitted, a node needs to send the data. Now, before that, it performs polling, and on the basis of polling, and on the basis of the count, the number of resources have been consumed, only that node will be allowed to send the data. This is the concept of spin. Now, in this spin approach, we are basically using data-centric routing, right? So here we are just thinking about transmitting the data, and before transmitting the data, we are checking whether the data has already been received or transferred. Only information, no redundancy should be there. And second, we are also checking whether the resource is sufficient to send the data, or the node which is having the maximum number of resource, or which is having the maximum consumption of the is having a minimum number of resource consumption, will be able to send the data to the destination node or the intermediate node. So because we are it is based on data centric routing. Now we are able to eliminate all three problems of flooding. Now in spin approach, we are following the three-stage protocol, which is called spin 1. Now spin 1 is a three-stage protocol. It uses mainly three types of messages to communicate for the communication between the nodes. Now nodes are using three types of messages to communicate. The number one message is ADV, second is the request REQ, the third is the data. Now ADV is used to advertise a new data or to request a new data, to advertise a new data. Request is used to REQ is used to request for the data, and the data is an event. Data is for the actual message. Whenever we are transmitting the actual data or actual message, data is used. Now let's see the nodes that are interested in the event or are interested in the data sends or transmits the request message to the source node. So every time a node is interested in receiving some data or any kind of information, they transmit they transmit a message REQ to the source node. Now after receiving the request message, the source node, which has gathered or sends the data, which is having that data which needs to be sent, the source node sends the data message to the interested node. And in this way, the data can be sent or delivered to all the interested nodes in the entire network. So let's see the advantages of this spin three-stage protocol. Now, first is it is very simple. We are using just three messages and we are communicating between the nodes using these three messages only, so that no redundant data should be there, no wastage of energy, no wastage of resource should be there. Second advantage is that each node performs little decision making. Of course, they are having resource manager, they are having table also. So here the polling is also performed. So here every node is taking a decision. Therefore, it wastes a very little energy in consumption, because every time the data is being sent, the nodes are responsible for taking a decision whether the information should be sent or not. So because the decision is taken every time the data has been sent, so the energy consumption is there, but it is very less as compared to the previous approach. The third advantage of spin 1 is that each node only needs to know about its single hop neighbor. Now, because I don't have to consider the maximum number of hops that I have been allocated, so I have to worry only about my single neighbor of the network, right? So in this way, how spin 1 works. So let's see in this. Let's see, we have A, B, and other nodes also. Now the nodes which have been colored as a black circle, they are already having the data and they do not require it. So they are not transferring or sending the acknowledgement or request. Now these black colored nodes shows that they have already received, like using this ADV request and data messages, they have already received the data, and A is the source node which is sending this data to B, and B is broadcasting now to the other neighboring nodes. So in this way, only the data is transferred to the requiring nodes. Not only the data is sent to the requiring nodes, but also unnecessary broadcasting or flooding of the messages has been stopped. Right? So these were the approaches, these were the methods through which data dissemination is performed, and data dissemination is nothing but sending or routing of the data in the entire wireless sensor network. So this was all for today's lecture. Next, again, I'll be back with new topics. Thank you very much.